Welcome to our notes on matrix applications. Students will be able to solve any system of linear equations using a calculator. And students will be able to explain verbally and in writing the process for finding the solution of a system of linear equations using matrices. So let's look at a 2 by 2 system of linear equations. Back in algebra classes, you have learned how to solve systems of linear equations when it's just x and y. You might have also looked at a 3 by 3, but we'll look at that later. So hopefully you can recall that we taught you 3 ways of doing this. If you solve the system graphically, you're finding the point of intersection. That's the x and y value that satisfies both equations. We've also taught you the substitution method where you solve for one of the variables and you plug it into the other and do a bunch of, algebra work and manipulation to find the solution that way. We also taught you the elimination method or the addition method, depending on which teacher you might have had, in which you line up your x's like we do here, and you line up your y's like we do here, and you line up, the constant on the other side of the equal sign, and you do a linear combination of things. So that way is quite tedious. It's something we can do, but let's learn how to use matrices to do this a little bit faster. So first thing I'm going to do is I'm going to kind of break it down for you a little bit before we move into our steps. So I could write the matrix negative 7x minus 8y, negative 4x plus 9y. That's a 2 by 1 matrix right here. And that would equal my constant like this. So already we're starting to see how this could be turned into matrices. Now the next step to breaking this down even more, because I won't be able to put x and y into my calculator the way I wrote it here, is I'm going to come to step 1 using the coefficient matrix. The coefficient matrix is very simple. Okay, once you've lined up your x's and your y's, you're just going to write the coefficients. So the coefficient of x in the top equation is negative 7. The coefficient of y in the top equation is negative 8. The coefficient of x in the second equation is negative 4, and the coefficient of y in the second equation is 9. Now, if you remember how to do matrix multiplication, the variable vector will make a lot of sense here. So the variable vector here, I'm using x and y. If you actually multiply these together, you will get this matrix that we wrote up here, okay? And we're going to set that equal to our constant vector, 9, negative 22. All right, step 2, we're going to use inverse of the coefficient matrix to get the variable vector alone. So remember, if we had something like, don't write this down, but if we had something like 2x equals 8, in order to get x by itself, we would divide, right? Well, we can't actually divide matrices. So what we do is we use the inverse of them. So if you were to take the inverse of both sides, you would get the variable vector by itself. Okay, and be very careful. The inverse must go in front of the constant vector. Okay, you can't interchange them. Okay, so the inverse of the coefficient matrix, and I'll show you how we write that on paper. We write it to the negative 1. Okay, just think like this is the reciprocal, right? Dividing by 2 is the same thing as multiplying by 1/2, and 2 to the negative 1 is 1/2. So I like to think about it that way, but this actually means inverse, so that can be confusing. And then we have this constant vector right here. So be very careful, that must go on the left side. Go ahead and grab your calculators. We're going to show you how to do this. You're going to make sure you're in your home screen. Then you're going to press second x to the negative 1, and you're going to go into your edit to type in your first matrix. So I like to put my coefficient matrix in A. You can do whatever you want. This is a 2 by 2. So I'm going to do 2 by 2. I'm going to type that in. Okay, it should, okay, there we go. So the 2 by 2 is negative 7, enter, negative 8, enter, negative 4, enter, 9, enter. Okay, so just double check that your matrix, your coefficient matrix is all set. Now you're going to quit, and then you're going to go back into your matrix, and then you're going to go to edit, and now we're going to hit vector B. This is what I like to put my constant matrix in. I have a 2 by 1, so I'm going to go ahead and enter that. I have 9 here, and I have negative 22 there. Then I'm going to second quit and go back to my home screen. So now that I have both of my matrices in here, I'm going to call them to my home screen by going to second, x to the negative 1, which is matrix. I'm going to start saying the matrix, or second matrix now. It's a little bit easier to say. So I'm going to call the first one here, that's my coefficient matrix, and I'm going to press this x to the negative 1 so that I can get my inverse. And then I'm going to call the second matrix B. You can either press 2 or scroll down and press enter, that's fine. And then I'm going to press enter, and it's going to give me a vector 1, negative 2, and I'm actually going to write this on my paper. Alright, so now we used our calculator to solve it, so all that's left is to write it on paper. We ended up getting this vector, so what I'm saying is x equals 1 and y equals negative 2. So this point 1, negative 2 is a solution to the system negative 7x minus 8y equals 9 and negative 4x plus 9y equals negative 22. So that's just one way of solving it. I will show you how to do this using the augmented matrix. So let's try the augmented matrix. This one looks a little bit different. This one, I'm just going to write one matrix instead of 3. And it's going to look like this. So it's going to be kind of like the coefficient matrix first. So negative 7, negative 8, negative 4, 9. And usually on paper what we do is we see a line like this so that we know it's an augmented matrix. And then I'm going to write my constant vector on the other side. So really what I'm going to be putting into my calculator is a 2 by 3 matrix. Alright, step 2 says we're going to use our calculator and we're going to find the RREF function of for our matrix. It stands for the reduced row echelon form. I am not going to teach you the process of doing the reduced row echelon form, but I will show you how to find it in your calculator so you can solve systems. So let's try to solve this using the augmented matrix. So I'm going to go second x to the negative 1 so I can get into my matrix. I'm going to roll over to the edit and I'm going to change that coefficient matrix I had already started. I'm going to make this a 2 by 3. Okay, mouse work, thank you. Okay, so I'm going to make that a 3 instead, so it just adds another thing. I'm going to put my 9 in here, enter. I'm going to go ahead and roll over here to put my negative 22, enter. Okay, so now I'm going to second quit, so to go back to my home screen, and then I'm going to go back into the matrix real quick. I'm going to go over to math and I'm going to find RREF, so I'm going to scroll all the way down until I find it. RREF, be careful, we don't want REF, we want RREF. So I'm going to push enter here, and then I'm going to call my matrix A by going to second x to the negative 1. I'm going to call my matrix A under names, and then I'm going to press enter. I'm going to go ahead and I'm going to copy this down on my paper, and then we will interpret what that means. Alright, so if on paper, let's say we labeled this as matrix A. If on your paper you said RREF of A, then I know that you used your calculator to do it. Now just tell me what it says when you press enter. 0, 1, negative 2. Okay, now step 3, let's interpret the resulting matrix that we get. This one, and here I'll use a highlighter, this one right here is the x. So 1x plus 0y equals 1, so x equals 1. That's what that says, okay? That first row, 1x plus 0y equals 1. So this is x and this is y. Okay, so that means x equals 1. And the second one, the second number, let's use orange here. This one is my y value, so y equals negative 2. So again, this is 0x. Here, it's probably better that I write this out. So 1x plus 0y equals 1 is how I read the first row. And the second row, I read 0x plus 1y equals negative 2. Well, guess what? I don't need to write that 0y or that 0x. It says x equals 1 and y equals negative 2. So that's how I interpret the reduced row echelon form. So I think the augmented matrix is actually a lot faster, but if you like using the coefficient matrix with the inverse and all that stuff and matrix multiplication, by all means. However you choose to solve systems is how you choose to solve it, but make sure you write at minimum what you see in the steps here. Okay, so now here's a 3x3 system of linear equations. So if you remember doing these in your Algebra 2 class, these took a very long time to do, but matrices will help us save time. In fact, it will take us the same amount of time-ish as solving the 2x2. If it takes a little bit longer, it's because we have to enter bigger matrices. So I'm going to help you set this up, but I'm going to have you use your calculator in order to figure out the answers here. So let's go with using the matrix coefficient way, the coefficient matrix, I mean. The matrix coefficient here, okay, is -1, -5, -5, 4, -5, 4, 1, 5, -1. Remember, if you don't see a number in front of the variable, it is a 1. My variable vector is x, y, z, and I'm going to have that equal my constant vector 2, 19, -20. In order to use that, to move that coefficient matrix over to the other side of the equation, I need to use the inverse of it. So I'm going to rewrite that. So -1, 4, 1, -5, -5. Lots of 5s and -5s in here, but that's okay. We can deal. All right, so raise it to the -1. That's what it looks like on paper, I should say. And then you multiply that by the constant vector. I'm writing kind of large here. Okay, go ahead and put that in your calculator and solve and write your answer in step 3. All right, step 1 for my augmented matrix. This one is by far my favorite way because I only have to enter one matrix and not two. But, you know, whatever your preference is. So it's kind of like your coefficient matrix over here. Okay, and I'm just going to drop a line here, and then 2, 19, -20. This line should not appear anywhere in your calculator, so what you're going to do is you're going to set up a 3x4, and then you're going to get into your reduced row echelon form of this matrix. I'm going to call this matrix A again. I'm kind of running out of space, so I'm going to move it over. Should have done that first. So reduce row echelon form of matrix A. Tell me what that is and then interpret it in step 3.